Good morning, everyone. So I hope everyone is, all of you are feeling well this morning, despite the current weather conditions that we have right now. It's wet and it's cold. Sorry about the miscommunication this morning. We cannot go to the farm. Our bus is not available and the weather is not good as well. So today we will have lectures 6 and 7. We will continue with our lecture and I will upload a practical document or activity for you to conduct this morning. So for today's lecture, we are going to talk about coordinate systems and the use of georeferencing and also the use of geographic data, right? So with that, some of the points that we will be looking at georeferencing. We have conducted this in, I believe, in semester 2 of the first year of your course here in FBS 502 for surveying and mapping, where you had digitized a plotted map of our forestry complex. You had digitized that and submitted as your assignment. Eh? That is georeferencing. We will also look at spatial referencing, coordinate systems, digitizing, and data management. Now, georeferencing, this is defined as the location of an object in three-dimensional physical space by establishing its location in terms of the standard map projections or coordinate systems. Now, in simple terms, georeferencing is taking a point on the ground, locating it on a piece of paper, and taking that piece of paper or drawn map, scanning that map, and then encompassing a latitude and longitude coordinate on that piece of paper, then attaching that piece of paper on a geographic information system. Okay, like we did in our year 1 semester 2 class for surveying and mapping. Georeferencing is basically taking a scanned copy or a hard copy of a map and then attaching that with coordinates on a geographic information system. That is a very basic definition of georeferencing. Now, what does that offer? What does georeferencing offer? Now, if you look at the image on your right, something that you can notice here is, one thing that you can notice here is there is this image, it's called EV004 JPEG. So this here is an actual JPEG image or picture. This is a picture that that has been taken either from a drone, an aircraft, or any unmanned vehicle, or maybe just an aeroplane. Eh? So if you look at it, this image does not, if you look at the colors and the resolution, it does not look the same as the image on the background, right? So what happened here is they had taken an image from an aeroplane or a drone, tagged some latitude and longitude coordinates on that, and then place that picture on top of a geographic information system. Now, what does georeferencing offer? Now, it will convert what it says here is it will convert and conform all data sets to a common base map. Okay, a base map. What is a base map? We've already a base map. What is a base map? Talk about a base map. A base map is, for example, a blueprint where we reference all our vector and raster files. and user interface. For example, if you go to QGIS, when you open QGIS, QGIS is basically when we open the user interface, it's basically a blank white piece of background. Okay, with that blank piece of background, you can notice, you can identify latitude and longitude by moving around your mouse, but you do not know if your mouse is hovering above something, right? You would not know if your mouse is hovering above, let's say, hovering above this object or hovering above the top of a building, because you do not have a blueprint or a base where you can reference your pointer or your mouse on. Now, a base map is basically like a base blueprint where you conduct all your tracings on top. So it's like a basic blueprint or base map that you can trace all your drawings on top and reference all your drawings to. That is a base map. Now, georeferencing allows you to take pictures, take hard copy maps, and then attaching those copies or maps or pictures as a blueprint to trace on. Now, georeferencing takes those images and places it as your tracing paper or tracing base. Now, in addition to that, to a minimum level of georeferencing, there can also be further standardization related to coding. Okay, some countries, they use the global spatial database infrastructure, GSDI, NSDI system. So there are certain codes that you align your references images to. Like, for example, if you open our QGIS, and there is a plugin that you all know, which is HCMGIS. Okay, HCMGIS. In QGIS, this plugin gives you satellite images. Right? So these satellite images, when you load satellite images on QGIS, you notice that there is a certain different coding that it uses. Okay, it uses I think WGS or EPSG 3507. So that is a different coordinate referencing system, and that is a system that is used by websites, web-based data. So georeferencing, if you, for example, if you go through to the internet and you search for any type of company, right? If you search for any company in Fiji, what the web or the internet will give you is that they'll give you the name, the address, and on the side there'll be a small map, that is going to signify you this outlet is located here. Now that map is using our web-based coordinate reference systems. Let me just upload this. Okay. See, what you see here is right now what we can see is a blank user interface. Okay. So this white image here, this white background, this is your user interface. Whenever I say UI, it means user interface. Now, for this user interface, for example, if you notice here on the bottom, this is a coordinate system. Okay, it says latitude negative 0.989, longitude negative 0.359. That is your latitude and longitude. That's your coordinate system. These coordinates, they are in decimal degrees, and these are using EPSG or Coordinate Reference System 4326. This is a global coordinate reference system. Now, just look at this. If I am going to load my plugin, let's say if I am going to load HCM GIS, okay, if I'm going to click on that plugin, as soon as I load Google Satellite, notice that before it was 4326 down here, now it's 3857, right? This means that this image here, or this map, this georeference map is using this coordinate reference system. These are the various codes that is trying to tell us. Okay, if you go to the properties, go to information, you'll notice that it's using the name Google Satellite. This is the URL that the base map is pulling from the internet system. And these are all the properties of this base map for this coordinate reference system properties. Okay, it's using this reference system, which is WGS84 pseudo Mercator. Units are measured in meters. It's a projected system. It's using the Mercator system, UTMA, Universal Transverse Mercator, meaning that coordinates are given in meters. Okay. Before, while we were looking at before we uploaded the base map, we noticed that this was 4326 and your latitude and longitude were in decimal degrees. Now, when we have converted it to 3857, web-based coordinate reference system, notice that it's turned to numbers, which is meters. Okay, it's recording lat and longitude in the Mercator system. These are all the codes that accompany this base map. Right? So a base map allows us, for example, if I'm going to go to Fiji, okay, without a base map, for example, if this is switched off, I would not even know where Fiji is located. Okay, so the use from base map is to locate an area, and then if I want to, let's say, look for the Nosori Bridge and draw a vector or create a vector file, a shape file for Nosori Bridge, I can trace on top of this image, right? Because I have something, a blueprint to trace from. Now, if this image was not there, I would not be able to trace from anything. And that is the basic definition and use of a base map. When we talk about spatial reference, spatial reference is a series of parameters that define the coordinate system and other spatial properties for each data set. Okay, so the spatial reference is actually, if you right click on any layer or any base map, you go to information, these are all the spatial reference system that are provided. Right, the scale, the resolution, the height of the image, the reference system. Okay, those are the spatial references that are provided by that base map. So each and every base map requires a spatial reference. It allows the user, or it tells the user, if you're going to use this base map, take into consideration that the base map is using EPSG or reference system 3857. It's using the Mercator system in meters. It's a projected system. Okay, it's using a celestial body as the Earth. And the accuracy is 2 meters. These are the reference systems. That is what you mean by a reference system. Okay, and when we talk about spatial data is a data with a location component. It has a latitude, a longitude, a street address, and everything else that can identify the location of that point. As we all know, in a vector system, we have three main types of shapes, which is the point, lines, and the polygons. This is for vector systems. In raster systems are basically images. Coordinate systems, when you talk about coordinate systems, these are reference systems used to represent the locations within a geographic framework, right? So whenever you're going to use a PG map grid, right? PG map grid, we use the reference system. I believe it's three. Let me take you back here. The Fiji map grid system is 3460. This is a Fiji map grid. Now, what this means is using this reference system, with this reference system, majority of your projected shape files, you'll use an accuracy of the reference system with the Fiji map grid. Okay, let me just take you to this one. If I'm going to change my reference system to 3460, which is the Fiji map grid, notice that it's only highlighting these 2 points in red. This is because the projected system and the reference system is only suitable for Fiji. You cannot use this reference system for Australia, New Zealand, America, Africa, or somewhere else. It's only suitable for Fiji. If I'm going to apply this, it's okay. Notice that it's now 3460. What is the spatial reference of that? Again, the spatial reference system it was created in 1986. Okay, it's using the FNL22 grid, using transverse Mercator, meaning your map will not use latitudes and longitudes in degrees, minutes, and seconds. It will give you latitude and longitude in meters. Okay. And these are all the spatial reference that we use to create your WGS84. Now, these three references, if you notice this is 4326. This is like a standard. This projection system can be used by anyone anywhere in the world. However, it's a standard reference system and the accuracy may change according to wherever you are. 3460, it's a Fiji reference system, meaning that it's specifically for Fiji. And if you're going to use this in the Fiji map or anywhere on the ground, your accuracy will be very high. If you're going to use 4326 and 3857, your accuracy will be very low because these are standardized maps. These are not specifically made for Fiji. Those are what you mean by coordinate systems, right? Coordinate systems, when you talk about coordinate system, it's talking about latitude and your longitude. Something like X and Y system, right? So coordinate system allows you to pinpoint a location of an actual object. Now, as I mentioned and as I've showed you on QGIS, every single country has their own coordinate systems. There are two types of countries have their own projection systems, but for coordinate systems, there are two types of coordinate systems. This is the geographic and the projected system. Geographic is 4326 and 3857. These are standard reference coordinate system, and the projected coordinate system is the specific systems by country, country-wise reference system. Right? Now, when we talk about digitizing, now we move on to digitizing. If you look at these images here at the bottom, you notice that this is what you notice, this green part, this is actually a satellite image, right? This is a satellite image. And using that satellite image, this user here has drawn out the three fields, or the grounds and the ground and the buildings. Now, digitizing is creating your vector files. That is part of digitizing. Whenever you create, you're developing, you're also digitizing. Using this satellite image, this user has digitized the trees, the ground, and the basic shapes in the road. Whenever you're going to digitize, you need to plan, right? You need to be able to tell yourself and identify, if I am going to digitize vector files or vector system or vector shape files, what will these map or files be used for? Okay? For what purpose? If it's going to be for surveying borders and boundaries, you need to be able to use high accuracy base maps, right? If you're going to just create shape files for reference, just to inform someone, okay, this is the location of this, the person will not use it to actually create boundaries and borders. That means you can just use any type of, let's say, Google satellite image. Now, for boundaries and land surveying, you cannot use Google satellite because it is not specialized. So that is where this comes in, the purpose of this data. Coordinate system you're going to use, again, if you're going to use just it for reference, you can use Google satellite reference system, which is 4326. If you're going to use for accuracy wise, you will use for Fiji, you will use 3460 based on the accuracy. Right? You cannot use, whenever you're going to digitize, remember that you're going to be able, you need to use the most precise projection system. Also, whatever attributes you're going to use has to be projected to that projection system you're going to use it. That is basically today's lecture. So the main concepts that we have learned today is digitizing, drawing shape files or creating shape files using base maps. We learned about coordinate systems. There are two types of coordinate systems, the geographic and the projected system. What type of spatial data exists, vector and raster. We also learned about georeferencing. Now your practical for today is, I will give you a map and you have to digitize or georeference that map. Behind that map, you need to clip the layer and then you will print out that base map. Now what I will do is I will give you a basic, I'll give you an example. Okay, in the practical video, I'll give you an example and you will have to, you'll have to do that as a practical for this week. That's all we have for today's lecture. I'll meet you next week for our practical. For next week's practical, please come with your closed shoes at least be here by 9 a.m. Georgina, any questions? The end of the lecture. Anyone has any? No questions, so we will end our Zoom session here.